For part 1 of the Pencast, we are required to use the ideal gas law in order to find the volume for methane as an ideal gas with given conditions. For this, we are provided several pieces of information. First, we know the pressure. So we need to know pressure. We are looking for volume. We need to know molar mass. We have the gas constant, and we have the temperature. The pressure is said to be 1.45 times Earth's pressure, so that is 101.3 kilopascals times 1.45. Multiply that by volume, and that will be equal to, so methane is hydrogen, 1 carbon and 4 hydrogen, so that's 12 plus 4 times 1, so that is 16 times the gas constant, which is 8.314, times the temperature in Kelvin, which is 94 Kelvin. From this we get this equation, which can be simplified to, or rather solved for, which can be solved for this as the answer. For part 2, we are asked to use the specific heat formula. So we know that the dry ice will first go into a gaseous form and then heat up until it is 0 degrees Celsius. And we know that the water will cool down to 0 degrees Celsius and then freeze. So we are looking for how much ice you need to get how much dry ice you need to get the water to freeze but not cool down anymore. So this means that first we need to change state. So starting with the dry ice, first we need to change states to the gaseous form. So this will be mass times the latent heat of sublimation, which is 199 kilojoules per kilogram. This plot, and then we also need to heat it up to 0 degrees Celsius. So that'll be mass times the specific heat, which is 0.657 times the change in temperature, delta T, which will be going from negative 78.5, so 78.5. this is one side of the equation. The other side is the cooling down of the water and the freezing into ice. So first, with the cooling down of the water, we know that the mass will be 1, so it can just be exempt from equations because multiplying by 1 is redundant. So the specific heat capacity of water times the change in temperature, which it'll be decreasing by 20 degrees, so that's negative 20. And then you'll also be changing from water to ice, so that will be the mass, which again, 1, and then the latent heat, the latent heat of fusion, which is 334. Using this equation we derived, we can simplify this to, or rather solve, and we can find that 250.5745 m equals 250.26. So solve for m, and you can find that the mass of the dry ice will be 0.9987 kilograms. So 1. Assuming small angles, of course. And that is all. Farewell.